Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 7th, 2025, about 4 days ago. The big idea is a new task called dense motion captioning, plus a large dataset with about 60,000 multi-action sequences, and a model named Demo that delivers strongly better temporal localization and captions than existing approaches. The paper is titled Dense Motion Captioning. And as we'll see later, the combination of a rich dataset and a simple motion adapter plugged into a large language model has striking implications for 3D motion understanding. Alright, Figure 1 shows what dense motion captioning aims to deliver, segmenting a long 3D motion into discrete actions and writing a caption for each. Temporal localization means finding the exact start and end times for every action. The silhouettes illustrate successive actions, demonstrating how motion evolves across the sequence. The colored timeline marks segments with natural language labels, which ties actions to timestamps. This setup matters because real sequences mix many small moves, so precise boundaries keep captions faithful. Table 1 contrasts existing motion language datasets with the new benchmark, highlighting what each offers for temporal understanding. Well, Figure 1 showed the task needs precise segments, and this table shows most prior sets provide single sentences without timestamps. CompMo stands out because it includes dense captions with timestamps. The dataset lists 60,000 sequences. Average duration is roughly 40 seconds, which supports multi-action coverage. So, Table 1 set the stage, and Figure 2 shows that single motion captioning models score well on simple motions, but drop notably on complex ones. The radar plots compare several metrics, with simple sequences forming the larger green shape while complex ones shrink inward. CIDR, which is a caption quality score that rewards meaningful phrase overlap, especially highlights the gap. Models like Motion GPT and Avatar GPT follow the same pattern, which signals that longer multi-action sequences remain challenging. Figure 3 explains how the system converts long 3D motion into time-stamped captions using a motion adapter and a large language model. The motion adapter means a small encoder plus a linear projection that maps motion frames into the language space, so the language model can read them. The center panel shows Stage 1, Motion Language Alignment on Human ML 3D. The right panel shows Stage 2, Dense Caption Instruction Tuning on CompMo with LoRa, which adds lightweight trainable weights. Table 2 compares Demo with Unimotion and shows clear gains in captioning and localization. SODA is a caption quality score that balances precision and recall across segments, so higher values mean better holistic descriptions. On CompMo, Demo lifts SODA to about 18. It also boosts temporal intersection over Union to about 78. On H3D Intersect Babel, Demo nudges both captioning and localization upward, which indicates useful generalization. The motion text similarity columns rise as well, signaling tighter alignment between actions and words. So while Table 2 showed the quantitative gains, Figure 4 illustrates what those gains look like in practice. This figure contrasts ground truth segments with Demo and Unimotion predictions, using color bars and arrows to mark which captions align to which time span. In the upper sequence, Demo tracks many short actions with consistent boundaries, so captions match colors across the bar. In the lower sequence, Unimotion fragments events, whereas Demo keeps longer, coherent segments that reflect the described actions. Wrapping up, 2 takeaways stand out. Dense motion captioning reframes motion understanding as time-stamped, multi-action storytelling, and pairing a simple motion adapter with a large language model delivers clear gains on long, complex sequences. The broader implication is richer, temporally grounded tools for animation, sports analysis, and assistive systems. That is it for the AI Research Roundup. I am Alex. Thanks for listening.